Hello everybody. I'll be talking about how we applied inventory management and computer vision technology. It's all about ML. If you train the model well, and you'll go counting boxes. Let me briefly tell about who I am and what I do. My name is Andrey, and for quite a while I've been working doing data analytics. In ML, I have a PhD in mathematics, and for quite a while I've been doing classical ML and deep learning. I work at EPAM systems. And let me boast a little bit, Forrester recently named EPAM systems as a leader in computer vision vendors, amongst computer vision vendors. I will briefly put you into the context. Normally, when ML is applied to solve a certain task, the provider arrives to a certain industry and suggests solving a problem with computer vision, machine learning, or some other trendy hype term. And it turns out that those tasks were pretty well solved without ML. Turns out it was not that complicated. So what do we do with that? The classical computer vision project looks like this. You can find it on the slide or anywhere online. It all starts with the data. The data, then there's the training loop. We build the model, we train the model, then we make the version, another version of the model, check the quality of the model, check whether it works well in the real environment, in real production, and then we move on. That's a feedback loop. In computer vision today, they very often constantly use, I would say, the deep learning and convolution neural networks. Look at the slide. We have the image, and while using the convolution operations non-linearly, we are building from pixels. We get signifiers, we have fully connected layers, and after all of these operations, for the classifiers, for the classification of objects, we get the probability whether the object actually belongs to a certain group. Or we can conclude that the object on an image belongs to a class, and the class in this case is a cat. That's the object detection task. Again, this can be solved with convolution neural networks. We can do that both with classification and regression. It's not only about defining what is in the picture, but where is that in the picture with bounding boxes. This is the square that shows where the object is. We wanted to optimize the supply chain. What's the supply chain? A sequence of operations. For example, you arrive to the restaurant and want to order something. And before they even began cooking, this thing arrived from the warehouse. Then before that it was brought to the warehouse. Before that it was produced. In this particular case, it is important to take a look at the final chain in this supply chain, final link in the supply chain, which is the restaurant. So we have two guys who care a lot about inventory management, and we have the expeditor here, the one who arrives to bring all of these things. So the expeditor delivered the boxes that must be left, and some other box must be collected. So the box must be counted. And that could be in the middle of the night, in the snow, in the blaze. So that's why I want to help our expeditor. And this is a classical task of object detection. The use of neural network can help to build a system here, and that system will define where is a particular type of object. I mean, the box in this particular case. Let us look at this yellow stacks with boxes. Here, computer vision can identify only the stack. We need magic. We need to count all the boxes in the stack. So in this particular case, it is possible to identify which line corresponds to each box. We created a mobile app for that, facilitating the life of our expeditor. And of course, the feedback loop may change the quantity if necessary. Now we are at the restaurant. We want to count the boxes which are already at the restaurant because they deliver pallets to the restaurant. So the pallets are being unloaded. Look at the scenario. This is the typical restaurant scenario. There are at least 3 types of warehouse. An ordinary warehouse, the freezer, and the fridge. So the products are moving from there into kitchen in the end. And in a perfect world, it would be great to know what is the number of products at every single stage in every single type of warehouse. Why not? So we created a system that turned out to be quite universal. That system supports several cameras, detectors, classifiers. The system also supports a trajectory keeper, counter. Looks cool. And one of the typical examples here is that there are pallets delivered. And the idea here is to map the spot where they put the boxes, and it can be considered by default that the box goes there from the pallet, so it can be mapped onto the database. But there's a caveat here. The boxes are covered with QR codes so that it would be possible to know which box is where. This is not quite scalable, and preferably it could be just a little bit better. I mean, mapping every target zone with QR code is just a little bit too much. So, imagine that the person is interacting with the box. We can move into the embedding space. So we're moving into a different size of data. Say we have coordinates X and Y. We know where the box is, we know where the person is. But we can move into a space of a different size. So when the person interacts with the box, the human and the box are close. The other boxes that the person does not interact with one another are far from the person with the box. That is the surface level explanation, but it helps to understand what is happening. So, what's said is done. Now it is possible to identify that the person is interacting with the box and the other boxes are static, not interacting with the human. So it's about dimensionality and different grades of dimensionality. We use temporal relation networks to make this even better. It's, by the way, open source. Why not? So, the task to identify actions of the human is collection of a sequence of frames. This is the sequence of frames, and it is now possible to classify that this set of 8 frames describes certain action. In our case, this is the movement of the box from one point to the other. Now we tried it, and now it works. It is now possible to see that the person is actually carrying the box. And obviously, if the person does not interact with the box, does not carry it, there will be no false positive. Okay, now we can count the boxes. Cool. There's even no need to map these target areas. It is believed that the person took the box where it should be. Question: what's in the box? It's important to calculate all of the animals in the box, all of the elements in the box. There could be anything in a box. Packages, other box, transparent, untransparent. And it's important to have a system that would allow to compute all of that, to inspect all of that, so that we would have some understanding of what is being used in the restaurant, which products have been used. So we worked with our clients. We made a sort of a brainstorming, and we created a device. You see it on the picture. This is a high-tech device with lamps and the camera and the stand. The stand is necessary to actually put the device at the necessary height. This is the control point prototype. So, having this sort of device, it is possible to scale. And that is good, because this sort of device can be installed not only on the warehouse, but also in a fridge, even in the freezer, because this device is heated and it can work in an industrial freezer. And to all that, we can add a web app to put the pretty tablet so that the person will be able to control that things are going just fine. That's a feedback loop. We can improve and train the model more if it was not working well, or if, for example, there are new SKUs arriving onto our restaurant. But the value was not only about the fact that we have done all of that and automated this enumeration. We have also identified the taxonomy of errors. We have recorded all of the false positives, or the cases where the system was not able to detect. And we have found lots of fun mismatches between how restaurants work in the real life and how the charters say that the restaurant should work. I mean, the freezer, industrial freezer, are often used in the wrong way. That sort of freezer might cost up to $1 million, and if you don't use it the right way, you can easily break it. So you have to get a new one. So it was quite fun to see how the products are being used in the real time in a restaurant, by the way. Having had all those systems, we helped our expeditor, and you see that he's super happy and certain that the system is working, the system can compute everything, and he will not have to spend too much time on bookkeeping, because our system is very precise. No worse than a human being. And I believe that that's about it. I think I've been quite quick with my presentation. If you have any questions, please do not hesitate to write me. I'd be happy to talk to you online. There's an email. So I hope you enjoyed the presentation and you've learned something new and useful.